Welcome back. Today we have something really important in Python and in programming. These are conditionals and loops. Let's start with conditionals. Conditionals allow the code to run only if a condition is true. For example, if you have x equal to 10, let's pass this variable through an if statement, a simple if statement. The code inside the block runs only if the condition is true. Okay. If x is equal to 10, it means that if x is greater than 5, it runs. And let's check this right here. Let's experiment with this. X equal to, let's try 4 now. Okay. Store this variable. And let's if x greater than 5, print, and the code does not run. If it's like 8, it runs. Let's go to the next. If else statement. Now we have a different an if else. It means that if the first condition is true, it runs the first block of code. If not, if this condition is false, it runs the second one. Okay. Since x was equal to 10, it means that this was not true. It ran the else statement here. This is what it did. So let's try right here. So we have x equal to 8 if x. This is, we already know to practice. It's a good way to do it. Print else print. Exactly. And it's greater if we had like 4. The first x, okay, is less than 5. Okay, the first statement of if x was equal to 4, the first statement was true, and it ran this block of code. Now let's go to another type of conditional, if elif else statement, used when checking multiple conditions in order. For example, if x is smaller than 5, lower than 5, it print this condition. If it was elif x was equal to 10, it print this condition. Else, it printed this. Okay. You could fill a lot of elif conditions here and then finish with else. And let's try. Another elif, let's try. Very well. it's 4. Let's try now. 8, for example, to be different. Okay, very well. And let's try now 10. We should get exactly 10. And then 12. We should get the last one. Exactly. So it worked very well. More code here. Logical operators. We have to here, let's define the variable a as true, the variable b as false, and let's print, for example, a, and we have at least here 3 logical operators, and, or, not. These logical operators you learn in secondary school, in maths, philosophy also, for example. Learn to think about this, and let's write. The logical AND returns true only if both are true. Okay. Since one is true, another is false, since A is true but B is false, the result is false. Okay, we have it right here. Print A or B. This is the logical OR. It returns true if at least one is true. Since A is true, even though B is false, the result is true. Okay. Not A. Since we are here, A, this is the logical not, flips the value. Since A is true, not gives a false. And that's it. I can try it right here to practice. And let's print A and B. Exactly. Not A. Exactly. And this is expected. False, true, false. And let's try to mix things up. Both true. Okay. True. Since both since A and B are true, it gives true. Since it continues to be, let's try it like E, not B. It continues to be false, since now this true passes to false, and or we continue to have at least one true, so it's true. Okay. Combining now logical operators with comparisons. This we will do a lot in data science. Okay. Since we have, let's define the variable age equal to 25. If age is higher or equal to 18 and age is lower than 65, it means we have an adult. Okay. And that's what we have. Equal to 40, for example. If age higher than 18 and age lower than 65, print adult. Okay. And let's try 15. And what we have is the code doesn't run. Okay. Let's now go for loops. Loops allow to repeat a block of code multiple times. We have here a for loop. It iterates over a sequence, which can be a list, a range, a string, etc. For I in range 5, we print this iteration. We already know that range 5 goes from, it's a function that gives you values from 0, 1, 2, 3, 4, and doesn't consider the last one, the 5. So it prints 0, 1, 2, 3, 4. Exactly that. For I, let's range, if we had 10, it would not print the 9. What did I do wrong? Of course, it will, like here, don't forget, on these statements, we need this. And we print until 9. Very well. Iterating over a list. We have a list of variables which are, in this case, fruits, apple, banana, orange. So for fruit in fruits, in this list, print the name of the fruit in order. Apple, banana, orange. Very well. And fruits. Apple, banana, cherry. Very well. For fruit in fruits. Print fruit. And that's it. We started wrong here. Let's go to see. Okay. Apple, banana, cherry. So, two things, don't forget about this. And always start here at the beginning and then give a tab to consider print if you add this. I don't know if it doesn't consider, you have to give a tab, this space, for it to work. While loop runs as long as the condition is true, okay, we start, we define the counter, this number, as 0, while counter is lower than 5, it will print the counter, and the counter, and to continue the while, it sums 1, okay, for the next one, and this continues in while it's lower than 5. This is the same way the sum, writing this is equal to writing all of this is equal to writing counter just plus equal 1. It's shorter for programming when it's too verbose. But for beginners, I prefer this. It's easier to understand. So, and this gives this result. -5. Let's start here. Counter equal to 1 to change things up. Counter lower than 6. It should go until 5. Print counter. Okay, and define. Well, let's define it this way. It should go 1 to 5. 1, 2, 3, 4, 5. Exactly, okay? Because it stopped before 6 and it started at 1, and this is exactly the same as this thing right here. Equivalent. Loops and operations with arrays. We have here now, we import numpy as np. We will convert this into a numpy array, okay? Save it as ARR. We loop I in 0, 1, 2, 3, 4. And this means that in ARR we'll go to position I, which is position 0, for example, from this list, and look up the value I in ARR, which will be 1. And from this position, we will add 1. From the position 0, okay, we add 1. We have 1, we add 1, and we have the result 2. From the position 1, in ARR, it is 2, and we add 1, and we have 3, and so on until we have position 4 in ARR, which is 0, 1, 2, 3, 4, which is 5, we add 1, and we have 6. And now here we can also try to change things up. I don't want all of this, it's too much. For I in 0, 1. Let's try in 1, 2, 3. Let's now ARR I will be equal to ARR. Okay, and let's print ARR. And okay, we have this, for example, position 1 and position 4, they are the same, okay, they don't move because we choose to move only position 1, 2, and 3. These positions 1, 2, and 3, and on these positions we add 1. To 2 we add 1, 3, to 3 we add 1, we have 4, and to 4 we add 5. And we leave these positions, the first and the last, the same. List comprehensions. This is a compact way to create lists. We have here lists of squares. Okay. We have all of these. Let's see what it means. Range 5 generates numbers 0, 1, 2, 3, 4. We already know that doesn't include the last number, the 5. For each number x, okay, in range 5, we will calculate x squared. This will build a new list from those squared values all in one line. For example, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And okay. And let's try it right here. Squares in not RR in range, and let's try it range 5. Okay, and let's also create the X to be a bit different. No, in order to show exactly the same range, and let's print all of them. Print text, print squares together for us to see squared of 0, 1 squared, 2 squared, 3 squared, 4 squared, and that's it. List of even numbers. Now, for we'll have the x for x in this range if this the values in this range divided by 2 they have a remainder of equal to 0. So let's go step by step. Range 10 generates a number 0 from 0 to 9, doesn't consider the last one. For each number x, we check, for each number of these, we check the condition, this condition. This is the model operator. It gives the remainder after the division. If the remainder is 0, it means that x divided by 2 leaves no remainder, which means that x is an even number. Only numbers that pass this check are included in the new list. So from 0 to 9, the even numbers are 0, 2, 4, 6, and 8. And that's it. So let's start here just to try evens. X for x in range 5. Let's try it divided by 2x. Okay. And let's print evens. And it will have exactly that. Until 5, the even numbers are 0, 2, and 4. So that's it for conditionals and loops. We have then a few exercises in the next video. So thank you very much, and let's continue learning Python.